Good morning to everyone. I am Dr. S. Udayakumar, Department of Chemistry, King's College of Engineering, Punalkulam, Pudukkottai district. Today I am going to discuss about the topic of types of nanomaterials in engineering chemistry CY3151. So before we are going to see what is the types of nanomaterials. So what is nanochemistry? The nanochemistry is the combination of chemistry and nanoscience. It is associated with the synthesis of building blocks which are dependent on size, surface, shape, and defect properties. Let's see what are the basic concepts of nano. That means what is nano? Nano is nothing but it is 10 to the power of minus 9 or 1 billionth in size. Materials with dimension and a tolerance in the range of 100 nanometer to 0.1 nanometer. Example: metals, ceramics, polymeric materials, or composite materials. 1 nanometer spans 3 to 5 atoms lined up in a row. Human hair is 5 orders of magnitude larger than nanomaterials. Think about it, how the nanomaterials are very thin and very minute particle. The table gives the scale, that is 10 to the power of 3 minus 3 milli, it is called milli. 10 to the power of minus 9, it is called nano. 10 to the power of 6, it is called micro. 10 to the power of 12, it is called pico. 10 to the power of 10, it is called femto. So we are discussing nanoparticles. So 10 to the power of minus 9 in the scale, it is called nano. So nanomaterials. So what is nanomaterials? The materials are particles that have smaller in size, that is 1 to 100 nanometer range, at least in one dimension. So there are several forms of nanomaterials. One-dimensional nanostructure. It is one dimension has its size outside the nanoscale. Two-dimensional nanostructure. 2 of the dimensions are not in nanoscale. Bulk nanostructure. None of the dimensions in the nanoscale are in, that is all are above 100 nanometer. This picture, it gives very clear idea about the nanomaterials. The nanomaterials classification based on the dimensionability, that is 0 dimension, 1 dimension, 2 dimension, and so on. So the example also is given in the table. For example, 0 dimension, the quantum dots, gold nanoparticle like that, and 1 dimension also they have given some examples. So it shows very clear what is the size of the nanomaterials. Then we will see bulk materials, how the nanomaterials are differ from bulk materials. The bulk materials usually we can see that the bulk materials we can easily see by visible, that is naked eye. The bulk materials, the particles have more than size above 100 nanometer in all dimension. The example of the bulk materials include plaster, sand, gravel, cement, etc. The molecules, all are know what is meant by molecule. We will see what is molecule. The molecule, a group of 2 or more atoms that form the smallest identifiable unit into which a pure substance can be divided and still retain the composition and the chemical properties of the substance. However, the majority of the familiar solid substances on earth are not made of molecule. These include all of the minerals that make up the substance of the earth: soil, dirt, sand, clay, etc. So all of these contain many chemical bonds but are not made of identical molecules. This table it gives very clear idea about the distinguish between nanoparticle, molecules, and bulk material. So already we discussed nanoparticle, what is meant by nanoparticle, molecule, and bulk materials. In this table, it gives very clear idea about the difference between nanoparticle, molecules, and bulk materials. First of all, we will see the first property, size. The size ranges may vary for atom molecule, that is 10 to the power of 10 micron. Nanoparticle 10 to the power of 10 micron to 10 to the power of 9. Bulk material, the microns higher. Microns are higher. Then second property, number of constituting particle, one for atom and many for molecule. In atom or molecule. But in nanoparticles, 2 to several thousands. In bulk materials, infinite. Then third property, electronic structure. The electronic structure in atom or molecule is confined. Similarly, nanoparticle also confined. But in bulk particle, it's a continuous one. Then fourth property is geometric structure. The geometric structure for atom or molecule is well defined and predictable one. Similar to nanoparticle, also well defined and predictable one. But in bulk particles, the crystal structure decides. So example for the atom or molecule, sodium chloride or hydrogen chloride. In nanoparticles, that is number of sodium chloride. In bulk materials, gold bar and silver bar is the example for that. So this table, it gives very clear idea about the difference between the nanoparticle, molecules and bulk materials. Then we are coming to the subject, that is the topic, types of nanomaterials. Here the definition, properties and uses of nanoparticles, nanocluster, nanorod, nanowire, nanotube. So we are going to discuss. So what are the types of nanomaterial? One is nanoparticle, second one is nanocluster, third one is nanorod, and fourth one is nanowire, and fifth one is nanotube. So let's we see one by one. What is nanowire? The materials having length to width ratio is greater than 20. Example, metals like gold, nickel, platinum. Semiconductors like silicon dioxide, titanium dioxide. Insulators, indium, gallium. Molecular nanowires, DNA. The characteristics of nanowires. One-dimensional materials. It is a one-dimensional materials. Conductivity of nanowires are less than that of bulk materials. It exhibits distinct optical, chemical, thermal and electrical properties due to large surface area. Silicon nanowire shows strong photoluminescence. Synthesis of nanowires. The nanowires are synthesized by two methods, template assisted synthesis. Another one is vapor liquid solid method, that is called VLS. The template consisting cylinder pores within host material. The empty space are filled with the chosen material to form nanowire. Example, alumina, that is Al2O3, mica films, etc. Then second method, vapor liquid solid method. In it, absorption of surface material or gas phase into liquid droplets of catalyst. So due to nucleation, precipitation of source material formed. Further deposition of material at the interface of the liquid droplet, promoting the elongation of the seed into nanowire. Then we will see application of nanowires. It is used for enhancing mechanical property of composites. It is used to prepare active electronic components such as p-n junction and logic gates. Semiconductor nanowires are expected to play an important role in digital computing in future. It is also used in high density data storage devices. Then we move on to next one, nanorods. The nanorods, the aspect ratio in the range 1 to 20 with a short dimension of 10 to 100 nanometer. Characteristics, it is a one-dimensional material and exhibits optical and electrical properties. It is synthesized by direct chemical synthesis. Application, it is used in display technologies and micro-mechanical switches. Then third one, nanocluster. It is an intermediate state between molecules and bulk material, fine aggregates of atoms or molecules. They bound by forces which may be metallic, covalent, ionic, hydrogen bond or van der Waals forces. Size in the range from sub-nanometer to 10 nanometer in diameter. It consisting of up to couple of hundred atoms but larger aggregates containing 10 to the power of 3 or more atoms are called nanoparticles. Magic number. It is a magic number atoms in clusters of critical size with higher stability. Production of nanocluster from the bulk materials. The picture is shown very clear how the clusters will form from the bulk materials. The sources of cluster: supersonic nozzle source, gas aggregation source. Then application of nanoclusters. The nanoclusters are biocompatible, ultra small, and exhibit brighter emission, hence promising candidates for fluorescence, bioimaging, or cellular labeling. Nanocluster, along with fluorophores, are widely used for staining cells for study both in vitro and in vivo. Furthermore, nanoclusters can be used for sensing and detection applications. They are able to detect copper and mercury ions in an aqueous solution based on fluorescence quenching. Also, many smaller molecules, biological entities such as biomolecules, proteins, DNA, and RNA can be detected using nanocluster. Then we move on to nanotubes. Nanotubes are very familiar one. Nanotubes are a unique class of material because of their hollow tubular nanostructure with diameters in the nanometer regime. A nanotube consisting of either a single sheet of atoms or multi-layer wrapped to form a hollow core. Example, carbon nanotubes. The carbon nanotubes. What is meant by carbon nanotubes? We will see that. The CNT is a tubular form of carbon with a diameter as small as 1 nanometer length to a few nanometer to microns. Is configurantly equivalent to two-dimensional graphene sheet rolled into a tube. The carbon nanotube is characterized by its chiral vector. The figure is very clear. That is chiral angle with respect to the zigzag axis. So this shows that what are the structure of that. That is armchair structure, zigzag, and chiral structure. Types of carbon nanotubes. There is two types: single wall carbon nanotube and multi-wall carbon nanotubes. Can be metallic or semiconducting depending on the geometry. This picture gives idea how the single wall carbon nanotubes and the double wall carbon nanotubes. In double wall carbon nanotubes, there are two layers out there. You can easily visualize it. Then properties of the carbon nanotubes. It is a very strong, withstand extreme strain and tension, and possess elastic flexibility, highly conducting, and behaves like metallic or conducting materials. It has high thermal conductivity and kinetic properties. The uses of the nanotubes. It is used in battery technology and industries as catalyst. It is used in lightweight shielding materials for protecting electronic equipments. It is also used effectively inside the body for drug delivery. It is used in composites also. Applications. Many geometers including thin film, bulk powder, single cartridge can be prepared. Thermodynamically stable novel materials can be prepared. Applications of nanomaterials. Generally, first of all, in the field of medicine, nanodrugs for cancer and TB therapy. Similarly, nanoparticles function as nano medbots that release anti-cancer drug and treat cancer. Gold-coated nano shells converts light into heat, enabling destruction of tumor. Protein catalysis can be done using nanomaterials. Gold nanocell used for blood immunoassay. The gold nanoparticle also involves slow and selective release of drugs to the targeted organ. Nanotechnology is used to partially repair neurological damage. In industrial area, due to larger surface area, nanoparticles act as a good catalyst. Example, activity of gold nanoparticle. Nanoporous membrane filters dissolved solids and color producing organic compounds. Magnetic nanoparticles are effective in removing metal contamination. Next one, the embedding of nanoparticles on fabric makes them stain repellent. It is also absorbing all the bacteria and make the fabric odor free. Smaller amount of nanoparticles in car bumpers, can make them stronger than steel. Especially designed nanoparticles are used as a fuel additive to lower consumption in vehicle. Nanoparticles are used in the food industry as a novel packing materials and containers. Nanotechnology also reduces the cost of photovoltaic cells by 10 to 100 times in solar power. In electronic field, in electronic industry, the nanoparticle organic memory field effective transistor is created by combining gold nanoparticles with organic molecules. Nano wires are used to build transistors without p-n junction. Carbon nanotubes are used in nano radios. Metal oxide semiconductors field effective translator perform both as switches and amplifiers. And biomaterial field. The nanomaterials are used in bone cement and bone plast and joint replacement in hospitals. Nanotechnology is used to develop miniature video camera attached in blinds glasses. It is also used in manufacture of heat valves and contact lenses. It is used in dental implants and breast implant. Carbon nanotubes are used shielding materials against electromagnetic radiation in electronic equipments. Thank you. Thank you very much.